NET-203, Introduction to Networks. Okay, so we had the students, they looked up to see who owns this address. Well, the ICN distributed this address to NIAC. So here's NIAC has the intermediate device connected to the internet, and out here we have the ICN, which is our internet service provider. That's an I. Might not look like one. Here, it's an I. So then the network, part of it goes over here to the IT area, and the other part goes to the main campus. Well, they weren't going to give the entire IT department this address, so they subnetted it. They borrowed 3 bits. They drew the line right here, and they borrowed 3 bits. 3 bits would give us 8 networks, which we have calculated it down here. Over here we have 1, 2, 3, 4, 5 bits for the host part of the network, which would give us 30 available addresses, okay, to use however we want. So here's what we did. The first network was right here. Now that's a 27. Can you see why it's a 27? Prefix bits was 24, right? We got 8, 8, and 8. And then we borrowed 3 bits. So that gives us 27. And those 3 bits, if we were going to calculate the mask, 128 plus 64 plus 32 gives us 224. So then we calculated the first address. Here's the first address. It'd be 1. It would go to 30. 31 would be the broadcast. The next address, so that first one was all zeros. The next address right here with a 1 there, that 1 gives us 32. So here's the address, 207.165.226.32/27. The first usable address is 33. This is the network. And the last one is 62. 63 is a broadcast. 64 is the next network. First address available. Last one, 95 is a broadcast. And so then we calculated all 8 of the addresses. And so when we got down here at the bottom, let me use a different color here. So when we got down here at the bottom, we ended up with 224, 225 to 254, and 255 would be the broadcast. And so the next step from here, if you added another 32 onto here, 256, well actually then that goes here, and we got 227. So I asked the students, who owns this address? And they looked it up and they found out that belongs to Olwine. Olwine School's using it. And where did Olwine School get it from? They got it from the ICN. So here's a practical example to where, for example, this group of addresses right here, right, we can't use the broadcast, we can't use the network, but we can use 161 to 190. And inside that range is the address that we use for the work server. 207, 165, 226, 185. That's a public address that we use for the work server. It's out of this range right in here. So when you connect in from Puckwana, wherever you're coming in from, when it hits the router, it ANDs it with the mask, right? And then it looks. And if the address fits in between here, then it sends it this way. If it doesn't, then it depends on where these other ones go. Actually, okay, we'll leave it at that. Then we took a look at our scenario here, our addresses with our switches. And then we said, what happens if we want to add a couple networks? Okay, so we could take these bits and then we could split those. And the students, I had them work on it, they split it right here. So they could create, here, let me do this. So this side is the network side, so that would give them 4 networks. And this side, that'd be 2 to the 6th, or 64, so that would give them 62 addresses on 4 networks. Okay, so this would be the cutoff, this would be the first network, and then you could address that all out. Here's how we got 62 addresses. And then I mentioned they could create a couple loopback interfaces inside the router, and they could apply network addresses from this group they're going to create. Okay, so they got a little ways. They got some of the work on the router done. I talked a little bit about IP mask and the default. Okay, so up here is the example network. Whoops. Actually, what we did here was we did a, let me do that in blue. We said, you know, you could borrow it here, then you would have 8 networks and 30 hosts. There is a video that goes through this process. It subnet out the address, and then it configures the router and the switch to match. Okay, so here's an example of the last network that we didn't use. It's a /26. Okay, then we said, well, we could borrow 3 more bits, more or less draw the line here now, borrow 3 more bits, and now we can make 8 more networks with 6 hosts, right? 2 to the 3rd is 8, and then we have to subtract 2 off for the network and the broadcast. So then this would be the next network on there. This would be the first one, all zeros. Then when we put a 1 in right here, we would add 8 on, and that would be the next network. And we could actually make 8 of those. Yes, and then that is really representing variable length subnet masking. Right? Variable length. So this is where we got that address to do the variable length subnet masking. If we assigned these addresses somewheres in the network, they're all being used, but this one isn't being used, so then we can subnet that again and now get 8 more networks with 6 devices on each network. We will spend a little bit of time following up with this in the next session. That's it.